Now let's try the actual graphing example. So we're asked to graph two cycles of the function f of x equals sine of 2x. And these are the steps we're going to take. First, we're going to describe some characteristics of our future graph. Let's start with the amplitude. What will be the amplitude of the graph? Well, remember the amplitude corresponds to the number, or I should say to the absolute value of a number that stands in front of sine or cosine. Since there is no number written here, it means that it's actually 1. So amplitude is 1. Next, let's determine if it's going to be reflected or non-reflected graph, because that will determine how it starts at the first cycle. So for that, we again have to look at the number that's in front of the sine or cosine function to see if it's positive or negative. Well, we already said it's 1 that we have there, invisible 1, and definitely it's positive. We don't see any negative signs, right? So since it's positive, then graph will not be reflected. Now let's determine the frequency. We'll also denote it by capital B. And when we're given a function, frequency is found by looking at the number that stands right in front of the x. In this case, it's 2. So frequency is 2. Remember, the meaning of the frequency is how many cycles can fit between 0 and 2 pi. And finally, the period. Well, we really need to know period, because remember, that's exactly what we use to label the horizontal axis. So how do we find period? Well, we already know one formula that connects frequency and period. And the way we know that formula is that to find frequency, we have to take 2 pi and divide by the period. But that formula can be written differently. And if to find frequency, we have to take 2 pi and divide by the period, we can say the same about the period. To find it, we have to take 2 pi and divide by the frequency. So that's how we're going to find the period in this step. So I'll have to take 2 pi and divide by the frequency that we just found in step C. So it's 2 pi over 2. Well, that means that period is pi. And once we know period, we're ready to start labeling the horizontal axis. We just did that exercise. First, I'll place pi. That's the end of the first cycle. I'm going to split it into 4 equal parts. Next, I need to label the very first one. Well, it's always taking the period, pi, and multiplying it by 1 over 4. So it's pi over 4. Pi over 4. And since the first subinterval equals pi over 4, the rest of them have same length, and I'll find them by continually adding pi over 4. So pi over 4 plus pi over 4 gives me 2 pi over 4. Another pi over 4 gives me 3 pi over 4. Then it's 4 pi over 4, which checks, right? That's same as pi. And then I need to continue because I need 2 cycles. Well, I have an option of going to the left and labeling the negative values and producing cycle to the left of the y-axis. I'll continue to the right just for the practice sake. Since period equals pi, then the second cycle ends at 2 pi. Pi plus pi gives me 2 pi. Well, that I will split into 4 equal parts as well. And I'll continue counting. 4 pi over 4 plus another pi over 4 is 5 pi over 4. Then it's 6 pi over 4, 7 pi over 4, 8 pi over 4, which is 2 pi. Okay, that checked. Now let's go back and simplify all fractions that we can simplify. So 2 pi over 4 simplifies to pi over 2. 3 pi over 4 I bring down. I cannot simplify. Pi, then 5 pi over 4 I'll bring down. 6 pi over 4 I can divide out 2. So that's 3 pi over 2. And then 7 pi over 4. Like that. Okay, so we labeled horizontal axis. I'm going to erase all the scratch work. And I'm ready to start drawing the graph. To do that, I'm going to place all the key points first. The key points are minimum points, maximum points, and zeros. And I'm going to do that in order. I'm starting with the vertical axis. What kind of key point I should place on the vertical axis? Well, it depends on the function. Well, in our case, we're dealing with the sine function. So where does the sine function cross the vertical axis? Well, it crosses it at the origin. So that means that the first point is what we call 0. Which way does the graph of the sine function go after that? Well, since it's not reflected graph, it will go up, right? It will start increasing and it's going to reach its maximum point. So that's going to be the next key point that I'm going to place. But I also need to make sure that I use the right amplitude. So since we discovered that amplitude is 1, I need to label the vertical axis with 1 and -1. Now I can place the maximum point. It's going to be here. I'd like to remind you that all those x values that we placed on the horizontal axis, they will all correspond to one of the key points. So I will never gonna skip any one of those, and I'm not gonna put any points in between. So each will correspond to either minimum, maximum, or 0. And there's gonna be a pattern. So if I start at 0, then I go to maximum. After that, I go back to 0. After 0, my graph goes down, it's decreasing, and it reaches its minimum value. Then it goes back up again to 0. After 0, it's another maximum. Back to 0, then minimum, and then back to 0 again. So every other point will always be 0, and in between it's going to be maximum, minimum, maximum, minimum, that kind of pattern. Once you place these points, you're ready to connect them to produce the graph. Don't forget that it's a nice, smooth wave, so try not to make any peaks. Make it smooth and curvy. Okay, that's what I got, and you can always extend your graph a little bit further on both ends just to emphasize that, well, it's continuous wave. So yeah, these are the steps we're going to take to graph sine and cosine functions. Let's do one more example. So we need to graph two cycles of the function f of x equals -2 cosine of 2 over 3x. Let's follow the steps. First, amplitude. The amplitude is the absolute value of the number that stands in front of sine or cosine, so it's going to be 2 units. Remember, amplitude is the height. It's always positive. Is this graph going to be reflected? Yes, because we can see a negative sign. Frequency. It's 2 over 3. And now let's calculate period. So to find period, we have to take 2 pi and divide by the frequency. So that's going to be 2 pi over 2 over 3. That is same as taking 2 pi over 1, that's the numerator, and multiplying by the reciprocal of the denominator, 3 over 2. Okay, looks like we got 3 pi. Period is 3 pi. Now I'm going to place 3 pi on the horizontal axis, so right here, that will mark one period, one cycle. I will split that into 4 equal parts, right in the middle, and then each half in half, like that. And I'm going to start by labeling the very first value, which always equals to 1/4 of the period. So 3 pi, I'm going to multiply by 1 over 4 to obtain that value. So that's 3 pi over 4. And now to find the rest of the values, I'm going to keep adding 3 pi over 4. 3 pi over 4 plus 3 pi over 4 gives me 6 pi over 4. Remember, it's only adding the numerator and keeping the denominator. Another 3 pi over 4 gives me 9 pi over 4. Then it's 12 pi over 4. At this point, I need to check that I'm on the right track. Yes, I am. 12 pi over 4 simplifies to 3 pi. I'll keep going since I need 2 cycles. In this case, I already know that the second cycle will end at 6 pi. 3 pi plus 3 pi will be 6 pi. That second cycle I will split into 4 equal parts. And I'll continue counting. 12 pi over 4 plus another 3 pi over 4. 15 pi over 4. Then it's going to be plus 3. 18 pi over 4. Then it's 21 pi over 4. and 24, right? 24 pi over 4, which again checks, right? 24 pi over 4, that's same as 6 pi. Perfect. Now I have to produce the simplified versions of all fractions. 6 pi over 4, I can divide out 2, that becomes 3 pi over 2. 9 pi over 4, I cannot simplify. Then 15 pi over 4. 18 pi over 4, I can divide out 2. So that's 9 pi over 4. 21 pi over 4. Okay, and that's it, right? So that's how we're going to label the horizontal axis. Now I can erase all the scratch work. And I will also label the vertical axis. We said that amplitude is 2. So that means that I can place 2 and -2 on the vertical axis. And I don't really care about any other numbers on the vertical axis. I know that graph will go up to 2 and down to -2 as I sketch it. So let's start graphing. We start by plotting all the key points, 0, minimum, and maximum. What's going to be the very first one? Which point do we place on the vertical axis? Well, that is based on the function that we have and whether it's reflected or not reflected. In this case, we have cosine function, and we already noticed that it's reflected cosine function. Since it's reflected cosine function, it means that on the vertical axis, it's going to start at the minimum value, at -2. What happens after that? Well, after minimum point, it goes to 0. It keeps increasing and it reaches its maximum. So now I'll just have to draw that pattern. Back to 0, then minimum point, 0, maximum, 0, minimum. Make sure that you don't skip any of the values that you labeled. At every single one of them will be one of the key points. So check that. And now I can connect these points. Okay, that's what I got. Again, at the ends, you might want to extend your graph a little bit, but make sure that you curl it up, right? Because graph of sine or cosine function cannot go below minimum or higher than maximum point. So once again, these are the steps that you're going to take to graph the sine and cosine functions.